I'm having flashbacks to last shutdown right now, sitting in my basement making these lessons. Not a good time. Uh, but I remember folks mixing up slope intercept. So I will tell you where we're going, okay, or where we've come from and where we're going. When you say slope intercept, you don't have to write this down for now. Just follow. I'll probably give you another overview later on. Just maybe watch right now and try to understand. So slope intercept, when it looks like this, right? And obviously the slope is there, the intercept is there. The y-intercept, you should be thinking y-intercept. When it says slope intercept, it's particularly the y-intercept that you're given. This one is very good for graphing because you can just have your grid, you know where this is, so you start and then you use your slope to get you elsewhere, right? So emphasis on the y-intercept is there. It also works very good when you are given a graph, right? And you know exactly where the y-intercept is. Y-intercept on graph, right? If you have the y-intercept, you want to stick to this one. You want to stick to slope intercept. That's the go-to. That's the one you want to work with. Okay? Emphasis on the y-intercept, right? I talk about the y-intercept a lot. There's the y-intercept again. So if y-intercept is given, boom, go to this one. That's the one you want to go to. But the one we're talking about today, so this was 6.4, but you already saw this in chapter 5, by the way. This form, you've seen that. Dependent variable is equal to rate of change times independent variable plus y-intercept, right? You've seen this already. That's kind of what we've been dealing with most of the time. 6.5, it's called the, as you can see here, slope point, right? Slope point. That's a different form. You can actually get from here, from slope point, we can go to here. We can rewrite it by using algebra. But really what this one is, this one looks like this, and you will see it right now in the, oh, I'm starting with x, of course, to start with y. Y minus y1 is equal to slope times x minus x1, okay? And this one is good for instances where you have you want to graph it, but you don't know the y-intercept. You just know 2 points on this grid, right? And then so then you want to be sticking to this form, right? Or when you're given an equation, right? And you don't really know what this is. This is a question mark here, but you do know for sure, like it's very easy to identify 2 points that are somewhere on the line. You want to be looking at this form right here, okay? So when you don't know the y-intercept, we go to this one. When we do know the y-intercept, we're going to go to this one, okay? That's the biggest difference. So I would say no y-intercept, right? You don't have the y-intercept, you don't know what it is, you can't figure it out even by looking at the graph, we are going to use this one. If the y-intercept is given, we want to use this form, okay? And so that's the main idea today. And then we're also going to find out a way to get it to look from this to that. We're going to go rewrite this to make it look like that because we like this one more when it comes to graphing. Okay. So that's the warm up. That's the main idea today. That's where we're going. And then towards the end, like tomorrow and Friday, we're going to look at the standard form. And that one is fairly straightforward. But these two are the main players, okay, in this unit, okay, in this chapter. Okay. So grab a highlighter if you have one, okay. So slope point, form. It's probably very important. Have the equation for a linear function, slope point form of the equation of a line, the equation of a line that passes through, right, passes through and has a slope of m, we would use this form of it, okay? And I will make a note here. This is any point on the line. It could be the y-intercept, by the way. It could be, but then we go to the first form, the slope-intercept, right? So then you would almost dismiss this one as like, hey, I'm going to go to that other form. Let me zoom in a little bit. I think it's a little far, right? There you go. So this point, the x1, y1 that you see here, those are going to be the coordinates of the one point that you're given, okay? And I should say watch for double negatives. Right? That will turn to a positive. You gotta watch out for that because these negative, these subtractions here, they're always there, and depending on what the value of x1 and y1 is, would sometimes result in a double negative. So you gotta watch out for that. That's a very common mistake. But you've seen it in when we did the exponent laws. You've seen it in chapter 5 when we did the slope or rate of change. You're familiar with that, so it's not brand new, but I'm just making sure you watch out for that. Okay, so let's do some examples here to get you familiarized with this. Okay, graphing a line given its equation and slope point. So we're going to graph when it's given in this form, and you should recognize this by looking at it. Okay, so write the slope and the coordinates of a point on the line, and this is the slope point, right? So this is your slope. So for A, the slope is, you get it from here, okay? This is M, because this looks like this format, right? You can't miss it. The bracket, right? The bracket x minus a number. So the slope is -3/4. Okay? And then you pick a point. Point. And here you have to be careful. This here is x1. X1 is equal to 2. Okay? I know you're saying, hey, what about the sign, Mr. Dirksen? You kind of have to reverse it, okay? Because this is y1 is -3. And I'll explain to you why underneath here. You kind of have to imagine what happened for the equation to look like this. Let's go back to the original. To get the +3, you went y minus -3, right? That's how we got the +3 in there in the first place. This is what happened when somebody plugged it in. You first had a -3 value for y1, right? Equals to -3/4, and here it was minus +2, right? Just that 2 that somebody plugged in there. And so that's where these values come from. So whenever you try to get the point out of an equation that's already done, like a slope point form, make sure you change the sign of it when you take it out. So this point right now is 2, -3. Change signs when taking out of equation. That's a big star there. You change the sign when you take it out of the equation. Okay, so now we're going to graph the line. So this is B here. We're given a grid. So we're going to start with the point. Before we started with the intercept, right? We don't have the y-intercept, but we do have the point. So you always have to start somewhere. Earlier we started with a y-intercept. Now we're going to start with this point. So 2, -3. 2, -3 is right here. And then use your slope to guide you from there. It's a -3, so we're going to drop 3 and we're going to run 4 to get our other point. And this is the cheat when you're running out of runway, do the opposite. Go up 3, back 4. And you'll see that it will line up perfectly. Okay? And indeed, you could actually now say, hey, from here, 3 down, 4 over, boom, I land on the line again. 3 down, 4 over, boom, right? So there's just a little tactic to get you a point backwards. Okay? And then you graph and you put the equation down, right? So y plus 3 is equal to -3/4 x minus 2, right? Put it down, make sure you have this labeled. And I will highlight this point right here and highlight it on my graph. Start here. You always start with a point, then use your slope to go from there. And maybe I'll just add on my graph, right, that this is a three vertical change and a 4 horizontal. For every 3 drop, there's a 4 run, okay? And the same thing happened going backwards. And we're almost running out of time here. Okay, we're going to do this question before we go, and then we'll just continue tomorrow. Write an equation for this line, okay? So we're gonna graph is given. Find slope. So that's the first thing that we're gonna try to find here. The slope is, they give you 2 points here. So you can actually just connect them like this. And you know that you're dropping 1, 2, 3, 4. This is a 4 vertical change. And this is a 2, 4, 6 horizontal change. And we know that it's dropping. Therefore, we're going to put a negative in front of it, and we're going to say, hey, that's a -4 over 6, which turns out to be a -2 over 3 because the 2 goes in the 4 twice and it goes into the 6 3 times. Pick a point. P, right? You can pick which one you want. So let's go -3, 5. This one here. -3, 5. This is P. We're going to call this P. And we're going to call this one D, right? Because I will show you something else later, what that looks like. So now write, we're going to go based on the equation, right? It's y minus y1 is equal to slope x minus x1. This here is x1 and this here is y1. Okay, so there is no x2, y2. That's only when you're calculating the slope. But this is the random point that was on there. So y minus, what's y1? It's 5. Okay, is equal to, the slope is negative 2/3, x minus, and x1 is negative 3. So it's a double negative 3 like that. It's a double negative, I should say. So y minus 5 is equal to negative 2/3 x plus 3. And the bell is going to go. So I'm just going to leave it at this here. We're going to continue with that tomorrow.